Alright, what's up guys? This video is made for my pre-AP chemistry students who are at home right now because of COVID-19. Just a little message for you guys. I miss you all very, very much. Cannot wait to have you guys back in class next year. This video is going to go over the first math quiz in that take-home packet that I gave you guys, or that you guys are about to pick up tomorrow on Tuesday, which I just left at the school today, which is Monday. So the first part of this unit is about pH. So acidity and basicity, I guess you could say, how basic and acidic a substance is. There are 4 formulas that this math quiz has to do with. You've got your ionization of water, constant. You've got a formula to calculate that constant, which is your hydroxide ion concentration times your hydrogen ion concentration. Remember, pH is equal to the negative log of H plus. pH plus POH is equal to 14. So using these 4 formulas, we can solve any of the questions that we have below. So for part 1, our question is, you are given a solution with a known hydroxide ion concentration equal to 7.8 times 10 to the negative 4 molar. You are asked, what is the corresponding hydrogen ion concentration within the solution? Calculate the hydrogen ion concentration and show your calculations below and circle your final answer. And then I've actually given you the formula that you're supposed to use. But let's say you didn't know what formula you were supposed to use. How could we figure that out? Well, what do we know? What do we not know? And then we know what we need to solve for. So it says your hydrogen ion or hydroxide ion concentration is 7.8 times 10 to the negative 4. So our OH negative is equal to 7.8 times 10 to the negative 4 molar. Now we're asked to calculate the H plus concentration. So we don't know this. Well, which formula has one of these values? And we can solve for the other one. Let's see. Okay, so we also know this because it's given as a constant. So we know this, we don't know this. Well, the formula that makes sense with that is this guy right here. Kw equals H plus times OH negative, and we can just solve for H plus. So what I would do first is just rearrange this equation, and then you can solve for H plus. So to rearrange this equation, we can just divide by H plus. I'll show you what that looks like in slow motion. Divide by hydroxide. So we're going to move this to the other side. Algebra says whatever I do to one side, I have to do to the other. And my hydroxide moves over to the other side, it cancels. And then you're left with your H plus concentration is equal to your ionization constant of water divided by your hydroxide ion concentration. Then you can just plug in Kw and OH negative. So I'm going to rewrite that down here and actually plug in my values. And that's 7.8 times 10 to the negative 4 molar. And as you can see, this molarity is not going to cancel out with anything, so our units for H plus are going to be in molarity. And I forgot my calculator, so let me go grab that real quick. All right, got my calculator. Please forgive me, I committed the cardinal sin of chemistry, and I forgot my calculator. Make sure you use parentheses appropriately on this, otherwise it's going to mess you up. If you don't put parentheses around everything, it's not going to do it right. And we end up with 1 point, we'll keep everything for now, times 10 to the negative 11. My units, the only thing that's left is molarity. So those are the units in my final answer. Now, significant figures here, looking back at the original numbers that we were given, our significant figures are 2 and 2. So my final answer has to have 2. So we're looking at these front two numbers. This is 5 or greater, so we're going to round up. So our final answer is going to be 1.3 times 10 to the negative 11 molarity. And there we go. Now we're going to work another set of questions on a new sheet of paper. All right, so these next questions are also going to use these same formulas that we used in the previous question. And this question is, you work as a chemist at a chemical supply company, and you are given a solution with a known hydrogen ion concentration equal to 3 times 10 to the negative 4 molar by your boss. Your boss asks you to determine the following 3 things about the solution so that it can be accurately printed on the product's label. Show your calculations below and circle your final answer. So what they want us to solve for is pH, pOH, and our hydroxide ion concentration. Remember our formulas that we've been given. We've been Kw is a constant.
How to calculate Kw? Our pH is equal to the negative log of H plus. Excuse my penmanship. Still getting used to writing under a camera here. pH plus pOH is equal to 14.
So we've got to solve for all these 3 values. And the only thing they tell us that we know initially is that the hydrogen ion concentration, the H plus, is equal to 3.0 times 10 to the negative 4 molarity. All right, so we can really start anywhere we want to start. I think the most obvious place to start is going to be right here and solving for pH, because we know H plus. Our formula for pH is equal to the negative log of H plus. So this is a really simple equation. We just plug in our number and type it in. So pH is equal to the negative log of H plus. We'll go ahead and plug that in. 3.0 times 10 to the negative 4 molar. You really don't have to write molar if you do brackets, because brackets mean concentration and molarity. Just FYI, but we'll do it anyway. So when you do this, you're going to want to use parentheses. So we'll go negative log. Going to open up another parenthesis so it does this correctly. E to the negative 4, or you can put times 10 to the negative 4 exponent, however you want to do it. And make sure you put a negative in the very front. That's very important. Press enter. And we get a pH that makes sense. If you don't get these values, comment below. I do make mistakes. No units for pH. So pH at 3.52. So my question for you guys would be acid or base. It would be an acid. pH is less than 7. It's also going to be a weak acid because it's not less than 2. 2 or less. 2 or below 2 would be a strong acid. Okay, so pH equals 3.52. The next 2 questions, they want us to solve for pOH and hydroxide ion concentration. There's actually a lot of different ways to work these acid-base questions, but it makes it easier on you if you just take a minute to look at your formulas and pick the one that's the most simple. So the most simple equation here that's going to help us solve this is going to be this guy. pH plus pOH equals 14, because we know the pH. We know that the sum, or what's on the right side of this equation, is 14. So we can just solve for the pOH right there. So pH is 3.52 plus pOH, we don't know, is equal to 14. So then pOH, if we rearrange this, is equal to 14 minus 3.52. This is a positive integer, so we have to subtract it from both sides to get on the right side of the equation. And then we just subtract this out in our calculator. Some of you have probably already done that in your head, but I am old, so we're going to get a pOH of 10.48. And remember, your pOH scale is the opposite of a pH scale. So if your pH is low, your pOH is going to be high. And if you have a high value on the pOH scale, it means you're an acid. So if you understand the pH scale, acids are low, bases are high, then you know the pOH scale is just literally the opposite. Okay, so we solve for pH, we solve for pOH using these 2 equations, and the last one asks us for hydroxide ion concentration. So there's a couple ways you could do this. There's another formula you guys have where the POH is equal to the negative log of the hydroxide ion concentration. Now, we haven't really looked at rearranging this equation using the opposite of a log, but you can do that. You can plug this in here, solve for hydroxide ion concentration using the little e to the power of to cancel out the logs and blah, blah, blah. Way harder than it needs to be. The easy way to solve for this question, because we're looking for the hydroxide ion concentration, is to use this equation right here, because we know H plus, it was given in the original question, Kw is a constant self-ionization or auto-ionization of water. We know that, solve for that. So we'll rewrite our equation here. And then we'll plug in, or we can rearrange first. You're going to divide by H plus. It's going to cancel out. Your hydroxide ion concentration is going to equal self-ionization constant of water divided by H plus. And then we'll just plug those values in. Over. And make sure you use parentheses. If you don't use parentheses, it's really going to mess things up. It's probably one of the most repeated things I say in chemistry. All right. Plug that in. We get a value of 3.33 times 10 to the negative 11 molar. So that is our hydroxide ion concentration. We solve for the pH, the power of hydrogen, and we solve for the power of hydroxide. And of course, those are inversely proportional. So the next question on your quiz is about titrations. I'm gonna do a completely separate video on titrations because I think that topic just needs a lot more explaining. So please comment if you have any questions. I'm happy to answer them, or if I've made any mistakes, let me know in the comment section and I'll go back and try to fix it and make corrections to the videos. So again, miss you guys a ton. I'm gonna try to do these videos for the packets so you're not just left high and dry. And just let me know, email me if you have any questions.